Hello and welcome. Today we're going to be looking at question number 6 on the AP Chemistry 2011 exam for Form B. As always, we're going to be going through this entire question so that you understand how to go about doing these AP Chem FRQs and are ready to ace the AP Chem exam. If you like these videos or find them informative, please be sure to like and subscribe. And with that, let's get started on this question. Alright, so we're told to use the principles of molecular structure, intermolecular forces, and kinetic molecular theory to answer the following questions. So A, a complete Lewis electron dot diagram of a molecule of ethyl methanoate is given below. Alright, and we're asked to identify the hybridization of the valence electrons of the carbon atom labeled CW. Alright, let's see how we're going to go about doing this. So CW has three different domains. Right? It's bordering an H, it's bordering an O with a single bond, and it's bordering another O with a double bond. So it has three different domains, which means that we're going to have three orbitals together. So that we have the s orbital, and then we have our two p orbitals to make three total. Right? So we have the s and the 2p. So sp2. sp2 is going to be the hybridization state for this sp2, because we have our three domains, the s and the two p's give us our three orbitals that we need. Let's move on to part 2 of part A. Estimate the numerical value of the HYCXO bond angle in the ethyl methanoate molecule. Explain the basis of your estimate. Well, let's see. Let's make a text box so we can kind of think this through. Alright, so essentially, what's going on is that the CX molecule, or atom really, CX atom in the middle has 4 different domains. It has the O single bond, it has the HY, it has the H, and then it has the other C. So it has 4 domains. So for these atoms to spread out maximally, they make a angle measure of 109.5 degrees. 109.5 degrees is going to be the angle measure between those two, the HY and the O. HYCXO is going to be 109.5 degrees, and that is our answer. Let's move on to part B. Alright, part B, here it is. Ethyl methanoate CH3CH2OCHO is synthesized in the laboratory from ethanol CH2H5OH and methanoic acid HCOOH as represented by the following equation. Ethanol plus methanoic acid becomes ethyl methanoate plus water. And we're going to draw the complete Lewis electron dot diagram of a methanoic acid molecule. The methanoic acid is what? Acid is HCOOH. Well, this is going to be carboxylic acid. So we have C here, connected to double bonded to the O, and then connected to this O, and connected to another H. And that's going to be part 1 of B. Alright, let's move on to part 2 of this question. Yeah, we're not done with this question yet. We have an entire other page. But part 2, in the box below, draw the complete Lewis electron diagram of a methanoic acid molecule and a water molecule in an orientation that allows a hydrogen bond to form between them. Alright, how are we going to do this? Try to fit on the same page. Alright, so let's see. So we can draw our H here, to the C, connect to the O, to here. And then this hydrogen is going to be a partial positive charge. So it's going to be connected. To a oxygen here, which is a partial negative charge. which of course is connected to our 2 hydrogen. That's a water molecule. Alright, so we really don't need the partial signs. We can just put this up like this. And we have the bond, the hydrogen bond right here is going to be like that. The hydrogen bond between the O and the H. The negative polarized O and the positive polarized H. And that is going to be the hydrogen bond between the methanoic acid and the water. Let's move on to the next part, part C. Part C is, actually scroll down so we can see it better. Alright, part C, small amount of liquid ethyl methanoate, boiling point 54 degrees Celsius, was placed in a rigid closed 2-liter container containing argon gas at an initial pressure of 1 atmosphere and a temperature of 20 degrees Celsius. The pressure in the container was monitored for 70 seconds after the ethyl methanoate was added, and the data in the graph below were obtained. It was observed that some liquid ethyl methanoate remained in the flask after 70 seconds. The volume of the remaining liquid is negligible compared to the total volume of the container. And we're asked to explain why the pressure in the flask increased during the first 60 seconds. Well, what happened during the first 60 seconds? Right? Well, let's see. So when you're adding the ethyl methanoate, right, we're adding liquid ethyl methanoate, which is not going to be contributing to the pressure at all. And at the end, we're saying that we have a negligible amount of liquid ethyl methanoate, which means that it's all being converted to its gaseous form. Right, so essentially, the reason it's increasing during the first 60 seconds, so the pressure is increasing during the first 60 seconds since the liquid ethyl methanoate is okay, how do I spell that? Methanoate. That's no, it's still telling me no. Methanoate. I'll leave it. Liquid methanoate seems like should be right, but hey, nothing I can do. And since liquid ethyl methanoate is being boiled to become gaseous, increasing the number of moles of gas, and therefore increasing the pressure in the container. Alright, and that was part 1. That was part 1. Now we're going to move on to part 2. Explain in terms of the processes occurring at the molecular level why the pressure in the flask remained constant after 60 seconds. Let's think about this. So after 60 seconds, what happened? Well, after 60 seconds, we've gotten to the point where we're at equilibrium, essentially. So at equilibrium, we're not going to be changing anything since the rates are the same. So at 60 seconds, we have achieved the equilibrium vapor pressure of liquid ethyl methanoate. So the ethyl methanoate is at equilibrium, right? So the rates of evaporation of the liquid and condensation of the gas are equal. So the amount of gaseous ethyl methanoate is constant. So this means that the moles of gas are constant. Moles of gas are constant, so the pressure is constant, right? And we can move on to the next part. All right, part 3. They're asking us for the partial pressure of ethyl methanoate vapor in the container after 60 seconds. Well, let's see. So at 0 seconds, And at the beginning, we started right here at, what is that, 1 atmosphere. So we started at 1 atmosphere at 0 seconds, and we ended up at 60 and 70 seconds at 1.25 atmospheres. So we increased by 0.25 atmospheres, which means that must be the amount of ethyl methanoate vapor, the pressure of the vapor. Since we started with just the liquid, we started with just the argon gas at 1 atm, and now we're increased to 1.25 atm, which just increasing the ethyl methanoate vapor. So we added 0.25 atmospheres. So the partial pressure of the ethyl methanoate vapor is going to be 0.25 atmospheres. And we can move on to the next part. Alright, we have part 4 of part C. It is after 80 seconds, additional liquid ethyl methanoate is added to the container at 20 degrees Celsius. Does the partial pressure of the ethyl methanoate vapor in the container increase, decrease, or stay the same? And we're asked to explain. Again, we're told that the volume of the additional liquid ethyl methanoate in the container is negligible compared to the total volume of the container. So essentially, that part is not changing. Well, what else do we have? Well, the equilibrium here, right? The equilibrium excludes solids and liquids, only gases. So the equilibrium here is determined by the amount of gaseous vapor. So essentially, the equilibrium constant is just equal to the partial pressure of the gas vapor. Alright, so which means that if we add more liquid, then, well, the amount of gas is going to stay the same, so it's still going to be equilibrium, so nothing's going to happen. It's still at equilibrium. So our answer is that it stays the same. It stays the same. Our explanation, well, since the equilibrium expression is only influenced by gases and not liquids, the equilibrium is only determined by the amount of gas. Alright, we have already achieved the amount of gas necessary for equilibrium. So adding a liquid is not going to change the equilibrium, and the gas will stay at the same amount. So since the amount of gas is constant, then the pressure is constant and will stay the same as before. It stays the same. And that is our answer to part 4. Alright, that is it for this question. Be sure to tune next time when we go on to the next year, 2012. We continue looking at more of these AP Chemistry FRQs to help you on the AP Chemistry exam, and I'll see you then.